Hey everybody, Mr. Rohr here. Um, yeah, let's get going. So, Section 11.2 is an extension of what we've seen about interest. We saw simple interest, and so now this is compound interest. Quick review. Simple interest is calculated by just taking the amount that you invested, remember, called the principal, multiplying it by the interest rate. Remember, that's usually a percentage, but we have to convert the decimal, move the decimal spot over 2 spots, and then by the time in years. And then you often will take the amount of interest that you earned and you add that to what your amount was, and that's your final amount. So that's simple interest. What compounded interest is when um, you get paid interest multiple times. Um, so usually um, on a timely basis, like every month you might get some interest given to you, or every year you might give some interest. And if you leave your investment in there, then like the first time you get some interest, you get maybe this much. And then that investment's a little bit bigger now. And so the next time you get interest, it's a little bit bigger. Um, and so you get a little tiny bit more interest. And if you continue to keep that in there, it has this snowball effect, like as it rolls down um, a hill, right? It gathers a little bit more snow each time and it gets bigger and bigger and bigger. So that's kind of the heart behind compound interest. Here's a quick example. I wouldn't write this down. I don't think it's necessary. In fact, we're going to calculate some of these things in a different way in a minute. But if you started with $500 in an account and that account earns 6%, they might agree to pay you that um, semi-annually, which would mean twice a year. So you wouldn't get the 6% twice a year, but you might get 3% in July and then 3% of that in December and so forth. So 3% of 500 is $15. And so maybe after a half a year, you will have got $15 given to you. So that means you now have $515. Now, 3% of $515, that's a little bit more, right? That's $15.45. Um, and they'll add that to you, and now you've got 530 and 45 cents. And then the next half a year, now you're getting 3% on that, and that's a little bit more, and so forth. And so you're growing, but how quickly you're growing is getting faster. So at the end of 2 years, you might have $562.75. Now, this table, you can set up a table, right? You can do Excel or numbers or some Google Sheets or something like that, and you can make this. And the equations are relatively simple, um, but it's still a lot of work and kind of annoying to have to do all these calculations just to figure out how much you're going to have after 2 years. Um, and so rather than come up with some table and build this whole thing, I'd like to be able to answer this question immediately. And that's why we have a compound interest formula. Now, this looks really creepy because there's parentheses and there's an exponent and there's a big fraction in it and all that sort of stuff. It's not quite as scary as it looks, I don't think. So, it contains the amount that you started with, the principal. It contains the interest rate, which is going to be given to you as a percentage, but you're going to um, move the decimal spot over and write it as a decimal. Um, and then it's got N. That's kind of a new concept. N is how many times they've agreed to pay you per year. So that can be set up in a lot of different ways, but it's common to do that maybe monthly. So if it's monthly, then that means N would be 12. Um, if it's semi-annually, which we saw in the last example, then that's twice a year, so N would be 2. If it's daily, then you'd get 365 times a day, or maybe you use the common version of 360. Anyway, that's what n is, the number of times they compound it per year. And then t, once again, is the amount of time that you let this grow, measured in years, if the interest rate's given to in years. So that's the formula. Let's see how that looks in a couple of different examples. So we have $10,000 as our investment starting point. And so let's write that in here. Well, A is the final answer. That's how much we have, the amount that we have after 4 years. So 10,000, that's the P. And the interest rate would be 8%. So that's our R. But we typically don't put 8 into the formula. What we're going to do is convert that into a decimal. So 8% is 8 hundredths, which is 0.08. And then, sorry, don't know why the screen went all blue. It's kind of weird. There we go, fixed it. They said that it's compounded semi-annually. So that's a key word that you need to realize means twice a year. Let's make that blue. Boom. So twice a year means that n in this formula is going to be a 2. And then finally, we're going to let our investment grow for 4 years. So that means that t is 4. So there's the numbers that we need. So what I want to do then is put a 10,000 in for P. I want to put a 0.08 in here for R. I'd like to put 2 in for N. I'd like to put 2 in for N. And I'd like to put a 4 in for T. Now, calculating something with a formula like this can be a little bit of a challenge. And depending on what type of calculator you have, you may need to attack this a little differently. So let me write in all these numbers a moment. So 10,000 and then times 1 plus 0.08 divided by 2. Close that parenthesis, and then we're raising it to n is 2 again, times 4. So if you have a TI-83 or TI-84, one of those graphing calculators, I'm going to switch over to that sort of view a second so you can see my phone has a TI-84 type calculator on it. So if you've got something like this, a couple of things about it. You've got parentheses that are in the middle of the screen there. You've got an exponent button, which is this little caret-like symbol. And yeah, so those are some important things. But if you've got one of these calculators, you can type it in basically exactly how it looks. So 10,000 and then parenthesis 1 plus 0.08 divided by 2, and then use your arrow keys to get outside, and then raise to the, and at least the way mine's working, it's going to put this all up inside of the exponent there, so I can do 2 times 4 up there. And if it looks something like this, then your calculator is designed to do the order of operations correctly and handle everything. And you can hit enter and you can get an answer here. So $13,685.69. Sorry, that might be really small on your screens, but that's cool. That's nice. But not every one of you has one of these sorts of calculators. And so if you don't have one of these sorts of calculators, then what you're going to need to do is kind of chunk this, do it in pieces. And so I would suggest doing the 2.2 times 4 a moment. That's 8. I might do this part, 0.08 divided by 2. is 0.04. Then I might add the 1 to that. So if I add 1 to that, now I've got 1.04. So if I start or kind of write what I've got now, I got 10,000, and I'm raising this, or I'm multiplying that by 1.04 raised to the eighth. If you remember back in your high school classes and so forth, the order of operations, that's probably even middle school classes, but order of operations says that we need to do 1.04 raised to the eighth first, and then finally take that and multiply it by 10,000. So 1.04 raised to the eighth and multiplied by 10,000. So it still works, just several different steps. Again, if you have one of the graphing calculators sort of things that allows you to type things in parentheses and all that sort of stuff, I would encourage you to use that and probably type it the way it looks. But if you've got to chunk it, then that's how you kind of do it. Exponents first, this middle part to get the parentheses, and finally calculate everything. I'll try to show you that on the cell phone's version of the calculator. There. So if you got to do this sort of thing, a helpful hint, if you turn it sideways, you'll see more options. You probably know that already, but maybe not. And so we can do what? 2 times 4, get 8. We can do 0.08 divided by 2 to get our 0.04. We can add 1 to that, so we've got 1.04. And then the raised to the button, the exponent button, on this version is this guy right here. It says x to the y. And so if we type 1.04 x to the y 8, then we've got this 1.36 and all that sort of stuff. Finally, multiply that by 10,000. And there's our answer, $13,685.69. So, handful of different ways to calculate those things, and a lot's going to depend on what tool you're using to do it. So, I would encourage you to try this one. If you're watching at home or if you're watching in the classroom, maybe we hit pause a second, try to calculate it, and then come back and compare answers. Yeah, so oops, that's not the right button. Let me type in what you'd need to calculate. So $5,000 is your principal. We are earning 9% interest, so that is 0.09. It says compounded daily. So compounded daily would suggest that we're going to compound 365 times a year. So you can do 365 if you want, or 360 will be a slightly easier number to work with because 360 divides things nicely. So that's a common shortcut. And then for 3 years. So we're going to raise that to the 360 times 3. So that's what we have to type in. Let me switch to my graphing calculator so I can show you what that looks like in one calculation. By the way, if you don't have a graphing calculator, but kind of like this idea, the Calculate84 app, Calculate84 is a free app for iPhones and I think for other devices too. And it mimics what the TI-84 does and looks and feels the same way, but it doesn't cost $120. It only costs the $900 that your phone costs, right? So anyway, calculator for 84, 5,000 parentheses 1 plus 0.09 over 360 raised to the 3 times 360, and you'd have $6,549.60 after 3 years. Here's a slightly different question. So this is not asking you for how much you have, but how much interest you earned. So the formula, the compound formula, gives you your final amount, which is honestly what most people care about most of the time. But this question is saying, how much interest do you have? So you're going to need to compare the final total amount of money with the amount that you started with. And if you subtract those, that's going to be the amount of interest you earned. So let's see if we can put some numbers in here. And I'm going to show you on this one another calculator trick that maybe you'll like, maybe you won't, maybe you'll think it's too weird. But if you have one of these devices, it's nice to know how it works. Anyway, in this problem, our principal is 4,000, and the interest rate is 6%. So 6% is, remember, 0.06 if you move it over 2 spots. Compounded quarterly means 4 times a year, so n would be 4. And we want to know 2 years from now, so time is 2. Now, rather than typing all of these numbers in here, I want to show you how to use some variables. So, to do that, let me see. There you go. Now you can see the whole thing. Down near the bottom of this, it says stow. Stow is a store. So if you want to store numbers in for variables, you can do that. So I'm going to type the number 4,000, and then I'm going to press that stow key, and then the letter P. Now it's hard to tell on this screen, but above each of the buttons in here, there is letters. So above the 8, there's a little P. And so if you press alpha 8, that's going to put the letter P onto the screen. And I can hit enter. And let me also do the same for R. So I'm going to do 0.06 and the stow key and the letter R. And 4 and the store key and N. And 2 and the store key and T. Now the benefit of this is I can type the formula instead of typing all those numbers. So the formula is P, so alpha 8 to get the P on the screen, parenthesis 1 plus alpha R divided by alpha N, and then raised to the, and I can do N times T. Alpha log to get N on, and alpha 4 to get T on. And I personally can see this formula and feel a lot more confident that I typed that right than when I start putting all those numbers in there, I just get lost a little bit. So now if I press enter, it's going to put all the numbers in there. We don't see it, but it did that inside its brain there, and gave us our calculation of $4,505.97. Now that is A, that's the amount. I'm going to take that answer and I'm going to store that answer into A. I didn't have to retype it. If I just calculated it, when I press store, answer pops up there, and it's going to take that and store it into whatever letter I want. So let me store that in for A. And what I really want is the amount of interest we gained. And I said earlier that we can find that if we subtract A and P. If I do A minus P, that's going to give me the interest I have. So I already have P stored into my calculator, right? That was the 4,000 number. If I do A minus P, then the amount of interest we earned was $505.97. So anyway, kind of a neat little trick. Is it necessary? No, you could totally type this in with numbers, but it's kind of nice to be able to do that. So $505.97. Last concept in this compound interest sort of situation is the idea of present value. So a present value calculation is when you want to know what you need now to be able to get something specifically in the future. What present amount do I have to have in order to reach some sort of goal? So it's kind of like the calculation in reverse, right? Not I have this amount and I want to know what I'm going to have in the future, but the other way around. So there's a formula for that. The present formula or present value formula is this. That, to be honest, this formula is just a little bit of a reworking of this formula. If you divide both sides by this big chunk here, then you get this. I guess if you flip sides too. So I don't know that I would really count that as a whole new formula. I think this is really kind of the same thing. And as before, it's just we don't know what P is. But the textbook calls this a new formula, and I suppose you could think of it like that if you'd like. Nothing in here is new. P is the principal or the present value. A is the amount that you're going to have in the future. R is still interest rate, N is still the number of times they pay you per year. T is still the number of years that you let your investment grow. So here's an example using that idea. How much money should we invest today so that if it grows with 8% interest over the next 5 years, we have 30,000, right? That might be nice. My daughter's in 7th grade right now and probably will be doing college in about 5 years. And so if I wanted her to have $30,000 to be able to get that first year in maybe or something like that, how much would I have to invest right now? Assuming I don't add more to it as time goes on. That's a little bit more complicated type of calculation. So let's see what we have here. Just kind of list off our numbers here. The 30,000, that is the future amount. I want $30,000 in the future. Time is 5 years. The interest rate is 8%. And remember, interest rates, we don't put percentages in there, but we put decimals, so 0.08. And the number of times that this is telling us they'll compound things, how often they're going to break up and give us a little bit of interest. It's every 4 times quarterly, so N is 4. So if we want to use this calculation, 30,000 goes on top. By the way, if anybody wants a teacher appreciation gift, if you can give me a little like a thing that I can write on instead of having to write with my mouse, that would be really nice. Anyway, down here, 1 plus 0.08 over 4. And we're going to raise that to the 4 times 5. So whatever this calculates out to then is the amount of principal that I need, the present value that I need right now. And last time I did this using the calculator and all the letters and all that sort of stuff. And while I would recommend that, I get that you don't all have that ability. So let's do this one Let's pretend we don't have one of these nice calculators and we've got to use kind of a more normal calculator. Where did I put that? Oh, bother. There, calculator. So if I'm going to do this, I'm going to chunk it. So I'm going to do the 4 times 5 first. That I don't need a calculator for. That's 20. And then let's see if we can get this parenthesis a moment. So 0.08 divided by 4 is 0.02. And let's add 1 to that. So 1.02. That's the parentheses. So on top we still have 30,000. And we need to divide that by whatever 1.02 to the 20th is. So 1.02 raised to the 20th is this. And we've got 1.48594739 and all that sort of stuff. Oh, you can't see that. Duh. Let's make that a little bit more obvious. There we go. Something like that. I can just make this not as big. So now I need to do 30,000 divided by this. It's probably a good idea to write down as many decimal places. Well, you don't need as many as you need, but you probably should have 6 or 7 or 8 decimal places of accuracy here, because if you just cut it off and say like 1.48 and do 30,000 divided by 1.48, you're going to get an answer that's not equal to the right amount. So let's let me write it down. So 1.4859473959 and so forth. That should be good enough. So let's do 30,000 divided by 1.485947 and so forth. So that gives me $20,189.14. So $20,189.14. Let me do the same calculation and just show what would happen if I had rounded it to say like 1.5. So 30,000 divided by 1.5. Notice that's only 20,000. If I only save $20,000, I'm not going to have 30,000 after 5 years. I'm going to be a little bit short. It'll be 29,000 something. And so, yeah, you want to keep a couple of decimal places of accuracy here in order to get something that's accurate to the number, to the nearest penny. Anyway, that's a couple of questions about compound interest. That's a section 11.2. You've got a couple of problems on a worksheet that you should take a look at. If you're in the room and need an extra copy of them, I put those in the podium that are underneath there. If you're at home, you should be able to find that on Moodle. And if you have any questions, please email me and let me know how I can help. Have a great day or few seconds if you're going to watch 11.3 in just a moment.